She's worked on this project her entire life. Break time 50 Marthialans. Tile number 8 trillion. The swarm 17% complete. Back on Earth, nobody's cold. Nobody pays for the quantum leap. This isn't science fiction. The first tile went up in. Here at the Quantum Leap we write science fiction. It was 1960. Freeman Dyson was 33 years old. He'd spent 4 years on nuclear pulse propulsion, atomic bombs. He was thinking at civilizational scales. 2 pages in science. Not how to build one, how to find one. Freeman Dyson was 33. Break time 400 mens. He had one question. How would a civilization that outgrew its planet look from? His answer required building a shell around an entire star. Not metaphorically, physically, using the mass of Jupiter. It would capture every photon the sun emits. Everyone. 10,000 times Earth's total energy consumption. Forever. We're at 0.73 on the Kardashev scale. Type 1, a planet's entire energy output. We're not there. Carl Sagan first calculated this in 1973. We've barely moved. At current trajectory, Type 1 arrives in the 2350s. Type, unless something changes the timeline, and something has. In 2022, ESA released the Gaia Data Release 3. Every star, position, brightness, spectral type and infrared excess. Suazo asked, what would a partial Dyson swarm look like? A partial swarm would radiate waste heat in the mid-infrared. Not a signal, just heat, the fingerprint of harvested starlight. Suazo searched 5 million stars, looking for exactly that signature. When we saw this 2024 paper, we checked the methodology. 7 candidate stars with anomalous infrared excess, consistent with Dyson, not Tabby's star. These are muff stars, smaller, cooler. M-dwarfs have fewer natural explanations for infrared excess. Harder to. Before we go further, let's be precise about what. It is a preprint. Peer review is ongoing, no consensus. What the paper says, 7 stars can't be explained by. 2 categories remain, an unknown natural phenomenon or something built. 7 M-dwarf candidates from 5 million stars. The caution is breakthrough. Listen, point at the Green Bank telescope at the candidates. No radio signals, no artificial emissions. The absence is interesting. An advanced civilization might not transmit radio anymore. They've moved. This is Kardashev's insight. Energy scale determines communication strategy. So what are we looking for? What would finding it? Let's trace the engineering. The physics-constrained version, not the fantasy. The sun outputs 3.8 times 10 to the 26 watts. Every second. Humanity uses 18 terawatts, 1/4 of solar output. The gap between our use and solar output is engineering. Step 1 isn't a sphere. It's 1 tile, 1 square. 1 square kilometre at 1 AU captures 1.4 gigawatts. 1. You don't stop at 1 tile. Tiles build tiles. This is von Neumann's concept. Machines replicating themselves using local. Once the first self-replicating unit works, the math becomes exponential. Mid-video question, how long would it actually take? First, where do you get material for a structure that large? Mercury. Its mass alone could build 200 quintillion square meters, more than enough to enclose the sun. Material is there. The challenge, engineering at thermodynamic extremes. 400 watts per square, carbon nanotube webs, 100 times steel strength, far lighter. We're already producing carbon nanotubes. The challenge is 12 orders. Carbon nanotube production has followed a predictable trajectory since 2000 and the real breakthrough isn't the material, it's the solar wind. The Sun sheds millions of tons of plasma per second. A thin collector faces continuous drift, requiring active station keeping. The engineering solution: don't fight the solar wind, use it. Design collectors as stellar sails. Asymmetric reflectivity corrects orbital. Robert Fulwood calculated this in 1984. Same physicist who designed. The problem has known physical constraints and calculable solutions. Not. Back to the question from scene 50. How long would? So far, an energy problem, a materials problem, and they have one solution. Published in a 2013 paper, Eternity. In 2024, scientists searched 5 million stars for something impossible. They used the Gaia telescope. 3 years of infrared data. 7 stars had signatures that matched partial Dyson swarms. Not black holes, not neutron stars, something absorbing stellar light. The paper is Project Hephaistos. It has not been refuted. The researchers won't say what they think it is. These stars aren't producing the expected spectrum, too much heat. Unexpected stellar heat usually means debris disk, binary companion, or, for these 7 M-dwarfs, the first 2 explanations don't fit. That leaves 2 categories: new physics or something built. The contact generation now runs the telescopes. This is it. Back to the engineering, because the 2 threads are: Armstrong and Sandberg at Oxford's FAG ran the self-replication math. Eternity in 6 hours. About far more than Dyson swarms. From first self-replicating probe to full Dyson swarm, 280 years. Not fictional technology. Exponential replication using solar system materials already. The critical assumption: the first self-replicating unit. That's the only. In 2026, the closest research is DARPA's Autonomous Space Assembly. This is a projection from one study. Armstrong-Sandberg hasn't been. What the math establishes, the trajectory isn't blocked by physics. Here's where the threads converge. Any civilization past the self-replication. Dyson's argument in 1960. If civilizations exist, and some are, this reframes the Fermi paradox. What are their heat signatures? Jason Wright at Penn State runs GHAT, Glimpsing Heat. Wright's conclusion from the WISE All-Sky Infrared Survey. No Kardashev. Either advanced civilizations are rare or they don't expand. 7 Hephaistos stars fit the Type 2 profile. Now the real decision point, the scenario forking. In one version of 2040, the 7 stars confirmed as. In the other version, still unexplained. A new paper found. 2 Oxford researchers ran the numbers in 2013. Could self-replicating robots build a Dyson swarm using asteroid belt? Answer: yes. Timeline: approximately 280 years from first launch. Answer: yes. Timeline: approximately 280 years from first launch. The paper is titled Eternity in 6 hours. The math. The bottleneck isn't energy or materials, it's the first self-replicating. In 2025, Santa Fe Institute's DARPA-funded project hit 94% replication. 94% sounds close, but a 6% error rate diverges into DNA achieves under 1 error per 10 billion base pairs. The gap between 94% fidelity and DNA level fidelity defines the what does this mean for the next 50 years? The near-term answer isn't building a swarm. It's the cascade. Step 1 is already happening. Space-based solar power. ESA's Solaris aims for demonstration by 2030. China targets 1. These aren't Dyson swarms, they're the engineering generation that makes. It's 2038. Your home isn't grid connected the way it was. Your children's generation will debate the first self-replicating probe, as, in one 2050 version, the probe is authorized and launched. In the other, 40 years of delay. Someone else won. This splits civilizations, threshold crossers, and those that miss it. The gap exceeds what the Industrial Revolution created. That's not a prediction, it's a mathematical consequence of exponential. We're the first to ask, is that what we're building? 66 years after Dyson's question, we have the telescope. JWST can detect partial swarm signatures within 100 light-years, 10-0. The 2025 JWST survey of 47 systems continues. Results 2026. In 2027, the Square Kilometre Array reaches full capacity. If a Dyson civilization transmits anything, the SKA detects it. We're entering the decade where the Dyson question stops being. Freeman Dyson died in 2020. He was 96. He published, he saw Gaia launch. He didn't live to see Hephaistos. 7 stars remain unexplained, but the answer is coming. It's arriving within our generation's scientific lifetime. Here's the implication. Astrophysicists rarely discuss publicly the Fermi paradox. What if advanced civilizations are inside their Dyson swarms? A fully efficient swarm would be undetectable. The evidence of, we can only detect imperfect ones, civilizations that haven't. Visible civilizations are still building. When they finish, they vanish. The strangest implication, the most advanced civilizations may be invisible. We built the largest instruments in history to find signals. What if Fermi's silence is a signal we can't read? The first off-Earth human won't see themselves as an explorer. The civilization starting the swarm won't finish it. Descendants will. In 2026, Caltech's Space Solar Power Demonstrator transmitted energy wirelessly. That's tile 1, not of a swarm. Of the mindset. The contact generation is now answering Sagan's question. Dyson's 1960 question has been accelerating toward an answer for. If the answer to Hephaistos is yes, those are partial. Every religious framework, geopolitical calculation, long-term investment thesis revises simultaneously. Not because aliens are coming. Physics works for us too. Somewhere right now, the first Dyson swarm engineer is learning. They don't know what they'll build. Dyson knew someone would. 7 stars, still unexplained, full investigation pinned in the comments.